Well, hello. My name is Zack Schaefer, so I'm here to, is this too loud, guys? No, is that good? Okay, cool. I'm here to talk a little bit about microsegmentation. Does everybody know what microsegmentation is? I know you guys are a bunch of security guys, so we should probably, but kind of in and out. Okay, so I'll go into detail a little bit about microsegmentation. So segmentation, in general, is used to break apart your network to protect it from lateral movement. So in cases where you have a breach, it makes it much more difficult for an attacker to navigate through the network, because typically they come in and then they'll bounce around through the network to get access to weaker devices, and then you'll use that access to get data, which is what they're really after, right? So there was actually this is an advisory that was just released Monday. This came out. What's interesting about this advisory, this came from CISA. One thing that's really, really interesting is the number of agencies that tied together. In a total of 8 different countries kind of came together. So we're talking the UK, the United States, Japan, Germany, Australia, South Korea. And what's unique about this is this has happened before. You know, we've had other times where this many organizations, this many countries have banded together to help mitigate issues that are happening across the globe. But what is unique about this is just it just kind of shows us the magnitude of the problems that we're seeing right now. So in this particular case, it was they're highlighting some issues that they're seeing across the globe from sourced from China, specifically a couple different groups. One is APT40. APT40. If you guys aren't familiar with the terminology and the assignment of these different groups, it's basically an assignment that these organizations are tying to groups of hackers that they've found based on the threats that they're coming from. So this group in particular is also known as Kryptonite, Panda, and I think it's Bronze, Mohawk, and a few other weird terms, right? But these are the guys that they've been able to triangulate on based on where the sources of the attacks are actually coming from. And what's also really interesting about this is the way that these guys are getting in. So, what in traditional hacker, I think a lot of us think of hacking as using things like zero-day attacks, right? Using those things that nobody knows about to get in and actually penetrate your network. But what these guys are actually doing is something a little unique. So they're actually using known vulnerabilities, right? So they're going through. So CISA goes out and they figure out a vulnerability, they release it to the public as a known vulnerability. Here's what you got to do to fix it. This is the patch that you got to apply, or these are the mitigation techniques you need to use. What they're doing is they're preying on customers or companies that actually haven't been able to mitigate the issues yet. So that's what's really interesting. So they're using velocity to get into the network, because the challenge for us is that it's like, even though we might know about the issue, implementing the fix is not exactly easy a lot of times, because you got to navigate through all the change management. You got to get all these devices lined up to be able to actually push those updates, the software updates. You got to be able to implement those mitigation techniques across a global company is not trivial. So these guys are taking advantage of that and jumping in and actually penetrating the networks very quickly. And once they have that initial access, then they're going through the network, and they're using lateral movement to do that. And so they're using tools like SMB, they're using tools like RDP to navigate through the network to get access to the devices so that they can propagate their malware and get deeper hooks into the network. And they're using ports and protocols that are known and actually completely normal. So the firewalls are letting this traffic through, right? Because it's all part of the network. Okay. So this is definitely going to show my age. So this is a Mr. Owl. I don't know if you guys know Mr. Owl, but Mr. Owl is he was an ad campaign that Tootsie Roll had back in like the late 70s, early 80s. And they were there was this boy's quest to figure out how many licks it took to get to the center of the Tootsie Pop, right? And so he went to the turtle, and the turtle's like, "Go ask Mr. Owl. Mr. Owl will know everything." So he went to Mr. Owl. Mr. Owl got 3 licks, and then he bit it, and he said 3, right? And so but the point, it has nothing to do with what we're talking about today. But the point is, like, one of my customers likes to call his network a Tootsie Roll Pop, right? He's got a hard candy shell, right? Firewalls. And then he's got a soft inner core. Once you get past those firewalls, it's nice and flat and easy to propagate. So, I think it's very relevant to what we're talking about today. What we see a lot with how our customers are implementing mitigation techniques to prevent these types of attacks from occurring is with firewalls. Firewalls are usually at the perimeter. The challenge with firewalls is, once you get past the firewalls, then you're usually in, and usually it's pretty flat. And we're talking about, that could be something along the lines of, VLANs funneling up to firewalls. It could be something along the lines of VACLs or ACLs that are preventing access into certain networks. I see a handful of VRFs, so those are the macro segments, so those are the larger segments, but typically, and I supported enterprise customers in the Southeast for Cisco for about 8 years or longer, and the average number of VRFs that I saw was somewhere around 3 to 5 at most, right? Because it's challenging to support from an operational standpoint. So typically, most of the time, when we think about VRFs, they're still flat internally. Fabric overlays is a new concept, and so this is probably the closest similarity to what we're actually doing, and we're doing something that's a little bit unique, and I'm going to talk about that when we get into details on the architecture. But fabric overlays are something like, think along the lines of Cisco's software-defined access, right? And so what you're doing now is you're starting to break apart your network into smaller chunks and making them a little bit more manageable. The challenge there is that a lot of it requires a vendor lock-in. It's very, very complex. That's why the adoption rate is so low. So microsegmentation adoption is extremely low in the industry. Everyone says you should do it. It's like flossing. Like when you go to your dentist and they say, you should floss. And you're like, I know I need to floss, but I'm not flossing because I hate flossing, right? It's the same concept. We know we need to break these networks up into more manageable chunks to protect the data, but it's difficult to do, and so we don't do it. And so this is kind of what we're here to talk about today, is like, how do we make it more consumable? NAC is probably the most adopted of the technologies that are listed here, other than firewalls and VLANs and VRFs. NAC, the challenge there is that you got to have a supplicant. You got to be able to interrogate that host as it connects up to the network, and you got to have a specific port configuration that a lot of people just rip off when they have an issue, right? They go in, okay, this device is not authenticating. I need you to fix it now. What are you going to do? Take off that port config, let it connect to the network. It's wide open now. Nobody goes back and checks it, right? There's a guy at a big tractor company that we work with that his only job is to hunt for those port configurations. And that just sounds like a terrible job. I don't want to take his job away, but at the same time, I want him to do something else. I want him to do something fun that he would actually enjoy rather than be miserable. So NAC is an acceptable solution. The challenge is you got to have that supplicant, you got to have that port config, and you have to be able to do it on a device that supports a supplicant. Not everything supports supplicants, right? What happens when you have an IP camera, or you have a sensor, or you have a PLC, or you have devices that are built specifically for certain environments that don't support the ability to host a supplicant? That's the challenge that we're running into, is we're not accounting for every device, and we need to be able to account for every single device that's connected up to the network, because those are the devices that are getting targeted. So I'm not going to go through all these. I just want to highlight, this is from Forrester. These are some of the reasons what they see as far as why there's a lack of adoption with microsegmentation. For one, analysis paralysis. We have a customer that struggled for 3 years to implement microsegmentation with a big box vendor solution, right? They were battling with trying to make it perfect, the complexity that went along with it, and the cost. They just got to a point where they had to give up. They had to throw in the towel. The other big one is going big too soon. So when they say go big too soon, what that means is that you're trying to boil the ocean, right? You're trying to do it all. I want the perfect microsegmented network, and the challenge there is you can't. You got to start off with manageable chunks, and so a lot of our customers start off in a way that it makes it more manageable. So starting off something like binary, like the devices I trust, the devices I don't trust. Let's just start there, and let's figure out what we know about and what we don't know about. Make it very binary. And then the last one here that I'm going to talk about is enforcement anxiety. And so with enforcement anxiety, that's the scary part, right? So like, I got to turn this stuff on. So when I turn it on, I'm going to start blocking traffic. And what's the impact of that going to be? Am I going to get in trouble? Am I going to break something that needs to be up? So these are all things that kind of prevent or slow the adoption rate down for microsegmentation. So Glaxo is one of our public references, so I can talk a little bit in detail about what Glaxo is doing. But one of the things that Glaxo was struggling with was similar to what we were talking about before, was that analysis paralysis. They had gone through an adoption. They were trying to adopt microsegmentation. They had massive budget that was ready because they had some issues, and then they wanted to make sure that didn't happen any longer. Because ultimately, countries like China they're trying to get out of the world where they're actually considered the global manufacturer, right? They want to be on the other side. They want to be on the innovative side. They want to start making things that are of value that are sourced from China, in owning the intellectual property that's associated with that. And to get that, they have to go steal it in a lot of cases. And so in their scenario, they went through 2.5 years, and they had deployed 1.5 sites. So just to give you an idea of that's what that really looks like from an analysis standpoint. And they were looking at all sorts of different things. They had no knack, they had no visibility, which is really critical to understand what's connected to your network and to be able to develop policy around it. So they started to look at various different solutions. What they ended up finding was that they couldn't have a solution that was just allow a device to connect up to the network and gain full access. So they ended up testing one solution for about 2.5 years in change, and then they went and they found us. And when they found us, we can implement inside of a network in basically a half a day. Usually that's just accounting for problems. So when we talk about the different solutions that are out there, how we architect the solution is really, really important. The reason why we exist is because of all these challenges that these guys ran into. So they're roughly at somewhere around 17 minutes per site. That's give or take like how many switches they're actually deploying at the site. And when I say it's deploying, they're actually managing. The other big part of that is the number of sites per month. So that's the pace that they feel comfortable with. We could totally do more. It's just the pace that they feel comfortable with. So they've completed somewhere in the range of about 70 different sites, and they plan to do the next 180 this year and next year. So speed and time to value is one of those really big pieces for us. This is another example where, and by the way, I want to show you guys some use cases before we get into tech, because this is something that Rob thought it'd be valuable for you to see what drove customers to go to a microsegmentation based solution. So in this particular case, this was a top 3 flooring manufacturer. They were getting push from their umbrella company, from their parent company to implement a solution to solve for ransomware. Right, so they had to get something in place. One of the things that they had, it's a manufacturer, so they have to be able to go into an environment without any sort of interruption. They can't impact the environment whatsoever. They have to be able to implement in a very short period of time because they needed that time to value. And then the other piece is they didn't have a trusted source of truth, right? And so when we talk about triangulating on multiple sources of truth, they had all these different tools that we're using to figure out what those devices were that were connected to their network, but they didn't actually understand it all cohesively. It was all separate. So what part of this project was to build that single source of truth. And we didn't set out to be a single source of truth, but we kind of naturally do become that because we're an aggregator of identity, but we're using that data to be able to triangulate on those devices and use that for policy. And so what this looks like, and so they have all these sources kind of feeding into what we call identity graph. And I'll talk a little bit more about identity graph in just a second, but I thought this was an important concept to understand how they got to this, right? And so this is actually the process they went through. So they collected all their intel as far as identity goes, whether it's Active Directory, Clarity, CrowdStrike, Native. They're pulling that all together into one single cohesive identity or aggregate identity. And then they triangulated on the devices that they knew about and the devices they didn't know about, right? So the devices they knew about, they said, okay, good. Let's make sure they're in the CMD, we're good to go, right? We're going to go ahead and populate. In their case, they had actually chose ServiceNow as their CMDB, so they went ahead and added everything that they didn't know about in ServiceNow into ServiceNow for the trusted devices. The devices that they found that weren't part of that, right, the unknown devices, they actually set out to figure out what they were, right? And so they had a team, they actually called it No Device Left Behind. That was the program they called it, right? And so they actually went out and hunted down these devices, figured out what they were, what their business case was. Was it legitimate? Was it not? And so if it was legitimate, they went ahead and they added it into their ServiceNow. If it wasn't, they yanked it, right? And so that was their first phase. And this was what, back to the comment I made about boiling the ocean. You don't have to boil the ocean. Start off with something simplistic. The devices I trust, the devices I don't trust, right? And that's a tactic that a lot of our customers are actually using. Now, this is a top 10 healthcare customer in the U.S. They were looking at a few different solutions. One of them was Cisco SDA, which is software-defined access, and they were looking at how to do this with SDA versus what Elisity does. One of the strengths of Elisity is to simplify the implementation and the operations of microsegmentation, basically make it consumable. And so, what they did some comparisons between the two worlds, right? They looked at what they'd actually have to do from a full-time engineering standpoint using the SDA model versus the Elisity model, and what they found was, and that number is actually way more. It's like it's almost like so high that it looks like fake, but it was actually 16. But in this particular case, we just said 8 plus because it seems like so absurd. But that's the reality, and that's how complex those types of solutions are. And so the reason why Elisity came to existence was to solve for those challenges and come up with a solution that was easy to consume and easy to operationalize. Okay, so now we're going to talk a little bit about the architecture. So we try to make it simple. We have two main components to the architecture. It's 100% software driven. There's no hardware that's required unless you want it to be, right? So you actually have an option to deploy a virtual edge on hardware in an SSD if you wanted to. But there's two major pieces to this. Elisity Cloud Control Center. It's the brains of the operation. It allows us to build policy for our devices that are connected up to the network. It also allows us to learn about what is connecting up to the network and actually triangulate on what the traffic looks like. So, the Elisity Cloud Control Center has a second brethren, right? The virtual edge over here. The virtual edge is used as think of it as a liaison between the cloud and the access layer. So he's pushing policy to your existing access layer. So we operate in brownfield environments. We use whatever you guys might have from an access layer standpoint. That could be Cisco, that could be Juniper, that could be Arista. It doesn't matter for us. At the end of the day, we're going to be able to push policy to it. And then we collect telemetry from those devices as well. So we'll be pulling telemetry, like what are those devices that are connected to the network? We're going to figure out who they're talking to. We're going to use that telemetry to triangulate on them using something called the identity graph. And identity graph I'll talk about in a little bit here. But the other piece of that is once we group these devices together without any sort of agents, we don't require any sort of agents on those devices, we start to put them into these groups of similar or like privileges, and then we limit the access that they're allowed to do based on that. So you guys develop the policy. It could be custom. It could be based on what we recommend. But at the end of the day, it's all built underneath one single umbrella. And what identity graph is it's the ability to learn about the information about those devices that are connected to the network. So when we started to go down this path, we realized that for one, that we had to be able to be 100% accurate. So we had to be able to take any sources of data that we could get our hands on. And so these are some of the integrations that we have today. There's more that are coming. These are just the ones that our customers have requested. It's 100% customer driven so far. But what it is the ability to take so we're learning information from the wire itself, right? We're taking that, we're using native identity. But then on top of that, we're getting contextual level information from other sources too. So that could be coming from a Microsoft Active Directory. It could be coming from a Clarity. It could be like in operational technology environments, we use spreadsheets, because those are a lot of OT engineers or electrical engineers. They use spreadsheets to be able to track those devices. We'll pull them together and we build a single aggregate identity, which is what we're going to use to actually wrap policy around. And what it looks like from a high level. So what you're seeing over here is we're actually, these are the virtual edges here. These are not in the control plane whatsoever. These are 100%, or these are not in the data path whatsoever. These are 100% control plane elements. And what that translates to is it's just going to be used to collect the telemetry and push policy to the access layer. And so it's a one-to-many from a virtual edge standpoint. It's a piece of software that just runs inside of a Docker container. It can be deployed anywhere. At the end of the day, we just need layer 3 connectivity to the access layer to push that policy and collect that telemetry. So in this case, we're actually deploying, in some switches, they support the ability to do application hosting. So you can actually host the virtual edge on the switch, but they're ships in the night. They're two separate things. So they're just, it's managing that switches from a policy standpoint, but it's not necessarily passing the data plane through that virtual edge. The other way to do this is upstream, like inside of compute. You can actually deploy these if you have local compute at the site. You can deploy it on ESXi. Hypervisor really doesn't matter at the end of the day. It's just a Docker container. It's exactly the same software, whether it's running on the switch or whether it's running inside of ESXi or whether it's running in a colo as a central virtual edge, right? So it doesn't matter for us. It's just a point to be able to control the traffic that we're actually sending to and from the switch, right? The other in this particular model over here, what we're doing is we're actually controlling access between these devices inside the ASICs of the hardware. So in environments where we're concerned about performance, we're actually able to offload all of this into hardware, and it doesn't matter what vendor we're actually using. The way that we're actually implementing it is by far the most scalable way to actually do enforcement from a microsegmentation standpoint. And the model on the right is at the aggregation layer. So that's another model. So in scenarios, we're leveraging technology that not every single switch supports, right? And we're constantly adding more and more switches to the umbrella. And like you see a couple different vendors here, but there's more and more that are getting added all the time based on our customers' requirements. What you're seeing over here is a scenario where I might have some switches like in an operational technology environment, like Hirschmann's or Moxa's or something like that, where they don't necessarily support the technology, but that's okay. We can actually enforce up here as well. And when I say enforcement happens up there, what happens is, I might not be able to enforce between these two devices down here because these are on a support switch. I can collect all their telemetry and I can figure out who they are, but I can also enforce between these two devices down here. And so what that means is, even though these might all be in the same VLAN, it doesn't matter. VLANs don't matter for us. IP addresses don't matter for us. At the end of the day, the way that we do enforcement, it's by device, so it's based on identity. So we're actually pulling that identity graph data and putting that device into a group, pushing that policy down to the aggregation layer, and enforcing between those two different switches. So the blast radius is now just this switch, right, versus this whole set of switches. So that's the big difference there. And by the way, guys, if you have questions about this, yeah, please go ahead.
Could you explain again why IP addresses don't matter?
So we do use IPs, but we translate it. So the way that we actually build that identity graph is based on the devices themselves, right? And so VLANs, right? You could have different addresses across different VLANs, right? But for us, we're actually just enforcing based on device identity. The way that we're translating it to the switching language, we're actually doing it. We're actually using IPs to do that. But from a policy standpoint, you don't care about the IPs. You don't even see them from the dashboard unless you want to, unless you deep dive into it. That's the point I was making.
You're using the MAC address or something like that?
How
do you uniquely identify the device?
Yeah, it's going to be based on MAC and IP and then identity from those other sources that I was showing before. So these guys up here. So that's how we're pulling it all together. These are the vendors that we support today. Like I said before, we're getting ready to add others as well. One of our customers needs Meraki, another customer needs Hirschmann, another customer needs, I think those are the two big ones that are coming. As far as what the profiling looks like, so when a device connects up to the network, it's actually going to initiate connectivity. We're going to do initial discovery. We're going to figure out, based on native discovery, we're going to figure out what that device is, what the vendor is, what the model number is, so on and so forth. We're going to check any other enrichment sources. So we're going to pull together we're going to check, basically pull Nozomi, Armis, CrowdStrike, whatever you guys are using. At the end of the day, it doesn't matter. We'll check Microsoft Active Directory. We'll say, okay, do you know about this device? We'll enrich that device identity. We typically deploy in a learning mode. Learning mode is really, really critical for this. So we actually deploy it in a fashion to watch the traffic. Because a lot of times we don't understand what the policy needs to be. We have an idea of what they need to be. And there's some things that's like low-hanging fruit. Maybe I just say, printers should never talk to IP cameras, right? That's a no-brainer for me. But maybe like a PLC in an operational technology environment, that's a little bit more difficult to understand. So I'll put him in a simulation mode and then watch the traffic and see if I'm accurate with that. And then the third way is actually enforcement. So we can actually start to enforce. And I'll show you what that actually looks like inside of a demo. And then the last piece here is data analytics. So once we collect all that data, we want to send that upstream to our whatever our SIM is. It might be a Splunk, it might be a Cribble. At the end of the day, it doesn't really matter. It's just going to be a northbound traffic flow. Okay, how do we help? So just about every standards body on the planet is recommending microsegmentation. Or segmentation in general, right? Like we have to start to break apart the network to be able to protect it from lateral movement. So that's just like I was talking about before. Those hackers are starting to get into the soft point and then they're moving laterally through the network. And so whether we're talking about ISA 62443 breaking out the network into zones and conduits, or HIPAA, or ISO 27001, NIST, CISA, NSA is recommending it, FBI is recommending it, NERC, SIP, you name it. And so if you guys are interested, we do have some handouts that you can actually use that actually detail some of the differences between the different standards, which can help with studying too. So if you're interested, we have some extra copies of those. All right, okay. So I'm going to go through a demo, and I just want to show you guys what this actually looks like. So in this particular demo, we're basing it off of an OT standard. So we're using the 62443 model. So we're breaking out the network into zones. Think of us like a software-defined conduit. So we're built to break apart the network using software-defined networking. And we're going to break it into a few different zones. And so in this scenario, we're going to be using a feature that one of our customers requested. This is one of our big pharmas. They needed a feature to be able to override their CMDB. And so in this scenario, they wanted a label. They wanted to be able to say, okay, look, whatever my CMDB is telling me, I need to be able to override that with a label and put it into a particular zone. And so in this scenario, we're going to be using labels to control what zone the device is in. But this could come from any source, really. It could come from ServiceNow. It could come from a Clarity. It doesn't matter for us. We're going to be able to adapt dynamically based on the information that we're learning about that device. And so in this demo, we're going to basically take a device that's sitting in zone 1, and we're going to move it into a subzone. And that subzone is going to be much more restricted. So in zone 1, we're allowing devices to talk to each other inside the same zone, right? And what's interesting about this is that each one of these printers is identical. So meaning they're without that contextual level of information, that we would never be able to understand what level of access they should have. So that's that information that we're getting from identity graph. And so what we're going to do now is we're going to move him into the subzone, and we're going to limit access so that he can only speak to anything that's in subzone 1A, which is basically a historian, and he'll remove access from any of the devices that are inside zone 1. All right. Just give me 2 seconds. All right, and connect up here. So this is the actual device itself, and what it's going to show us is the connectivity for all the devices that it's speaking to right now. Eventually. All right. Okay. I'll let that load up, and we'll flip back to it. So this is what identity graph looks like. So these are devices that are connected up to the network. We're breaking them down into different groups. What we're going to look at is this zone 1 PC. So what we're seeing here is a couple different things. So we're learning about core effectored attributes, which is a translation of what the information that we're learning from all these different sources. We're pulling it all together. We're learning about what group it's in and what zone it's in, the policy set that's assigned to it. So we support different policies for different types of sites. We're figuring out where it's being learned from. Can you guys read that? Should I make it bigger? A little bit bigger. Is that better? No, too big. Yeah, too big. Okay, we're learning about the trusted sources. So we now know it's in Armis. We know it's in CrowdStrike. We know that that we've manually verified this. We know that we've learned about it from Clarity XDome. We pulled all these together. So we have Elisity data, what we're learning over the wire, right? And this gives us what it is, from a model, manufacturer, type of device, the grouping of device or the genre. Then we also have some manually verified stuff. This is the label that I was talking about before. We're going to use that to override the identity graph category for that device. The XDome, with Clarity XDome, we're learning about things like risk scores, right? We can build policy around if like Clarity, for example, they'll actually interrogate these devices, figure out if there's any CVEs associated with a device based on the particular operating system and if it's been patched or not. And so they actually can categorize if it's high risk or low risk, or we can actually build policy around the level of the risk score. So we could say, hey, any device that's inside of this greater than or equal to 50 from a risk score standpoint, put it into this group. Any device that's less than or equal to that value, put it into this group. Same thing holds true for CrowdStrike. We're learning about, so when we talk about CrowdStrike, we do have the ability to support managed machines too. So if you have machines that are actually being managed with agents on them, we can support those as well. You don't have to though. It's not necessarily required for our solution to be able to operate. But in this scenario, we actually are integrating with Falcon and pulling the data back and being able to use that data to build policy. For example, like ZTNA scores is something like that. All right. Let's go back and see if this is logged in. No, it's not yet. Let me try it one more time. Maybe. There we go. Okay. Okay, so we're just using an application called VMPing. It just quickly shows us if traffic is successful reaching the other host or not. And what you're seeing on the top row is all the Zone 1 hosts. What you're seeing on the bottom is that bottom right corner is the historian. So when we move this access from this device, we're going to actually limit the access to Zone 1, and we're going to gain access to the historian. All right. So in this policy, let's go over here to the policy real quick. So what you're seeing on the top here is the ability to set up different policies for different sites, right? We're doing it by vertical in this demo environment, but you can certainly set up policies for given sites because just about everybody's going to have a unique policy for a given site. You have the ability to even tune that down even further and say, like, I just want to see the OT assets, and so I just want to focus on these OT assets. So this is the demo that we're going to be going through. And so when you look at this matrix, this is what we call our policy matrix. This is defining the groups of devices that are allowed to speak to each other. And so we're starting to say, look, okay, I know that I only want to let my manufacturing Zone 1 devices talk to each other. And so wherever that intersects at, if it's green, it's allowing that access. If there's an asterisk on there, it's in simulation mode. So it's saying, okay, I think I know what this policy is going to be, but I want to make sure. So I'm going to put this in simulation mode, watch the traffic, and see if that's going to be accurate or not. Then the orange is actually creating a unique policy. So I'm defining specific ports and protocols that are allowed to speak between devices based on the policy that I set up. So it just gives you a quick and dirty on like what that looks like. And now we can actually see any traffic that correlates to it. So now we're actually seeing traffic that actually is getting impacted by our policy, right? And so if it has an asterisk, again, we think the policy, we were allowing the traffic through, but we think that's what the policy is. If it has a shield on it, it's actually enforcing the policy. So it's actually traffic that's actually getting blocked. And you can even see the exact specific traffic that's getting blocked here. So like, we're blocking some ping and some NetBIOS traffic between that device. And I'll show you just a little bit what that looks like from a flow standpoint too. Go back here. Okay, so let's go back to our device and we're going to move him over real quick. All right, Zone 1 PC. And we're just going to edit him, and we're going to move him from Zone 1 to subzone 1A. And we're going to save that. And so that's, okay. So now, you can see right now, before I refresh, that it is in Zone 1. It's in the manufacturing policy set, part of our distribution zone, Factory A. And if we go back to shoot, dang it. That is a quick timeout. Yeah.
I want to talk to the security admin about that.
That is super fast, right? Like it was like 30 seconds. Okay, so so now we've lost our access to everything inside of zone one. We can ping ourself, right? That's ourself here, and we've gained access into the story. So just like that's how quick it really is. The beauty of this is it's all done in hardware, so everything's being enforced in hardware. So there's virtually no impact to the performance, which is always the scary thing. But now you can see like that's we recognize the change in the policy. We actually pushed it down through the virtual edge. We go back to this guy, refresh him. Yeah, and now we can see that he's now in zone 1A, right? And so that's the change, right? And so the same thing, again, would hold true if we learned about information coming from another source, like Clarity or Armis or whatever you guys are actually using. In Microsoft Active Directory, maybe a user logged in, and we want to reflect that change. All right. And so if we go back to the policies, so now, go back to manufacturing. This just gives you an idea of what it looks like from a traffic standpoint, okay? And then the last piece here is when I start to develop policy, right, I need to be able to understand what's talking to what. And so, visibility is a huge part of this architecture. You have to understand who's talking to what. Because a lot of times people don't understand, like you might have a good idea on what ports and protocols. Maybe I understand my printers need to talk to my print servers, but you don't always understand, if for example, you have an HMI in that environment or a PLC, what ports and protocols it needs to be able to use to be able to actually build out a policy to support it and make it happy. And so if we look at devices, so you can look at it either via policy groups or you can look at it based on devices. And you can say, okay, maybe I just want to look at maybe my PLCs here. And you can see, like, okay, these are the ports and protocols that this is using in between what devices. And so when I start to develop policies, I can actually use this data to build that policy. And I can also use it to troubleshoot, like to figure out what's connected to what, right? And what's unique about this is the visibility. Oh, sorry, do you have a question?
Yeah. Will the tool help the organizations to identify devices that are not accurately captured?
Mm-hmm.
So the device just has been plugged into the switch. It didn't get into CNDB
Right.
yet. The label, the device type, the host name is on somebody's laptop's Excel spreadsheet,
Right.
but it was.
Maybe it's a new laptop, right, or something. It's a new laptop that somebody, it's a new employee. They're connecting up to the network for the first time.
Right.
We have no idea what it is, right? It hasn't been processed, right? Yes. So what that looks like, from a policy standpoint, is we have a group of what we call unassigned, right? And so what unassigned is, it doesn't mean that we don't know about it. We found out about it. We figured out what it is. But we also know that it's not in a CMDB, not a trusted source, so we're going to put it to a group of unassigned, right? And you can define what unassigned means. And like some of our customers, they define unassigned as internet-only access. Others define it as critical services like DNS and Microsoft Active Directory and things like that. But what it translates to is the customers decide how they actually want to handle it. Is what that really means. So it just lands in a group of unassigned. And so what that looks like, from an actual customer example, do I have it up? I don't think I do. Yeah, but it's just a grouping of devices that we don't know about yet. We don't necessarily fully trust. That's what that means. So that group would not be able to talk to any of my super critical trusted devices.
So for that internet access, how granular can you get that? Can we say only go to the internet, only go to Workday?
You can. It's today we don't support FQDN from that standpoint, but it's something we could add pretty easily if that's something that's required. But yeah, today it's based on CIDRs. Yeah, great question. Does that answer the question though, as far as how we handle it? We define the policy for it, is what it really translates to.
Yeah, I was trying to also identify, since you are taking metrics and then the configuration from the switches and the control plan and whatnot, I was trying to see if you would also like use to estimate the type of device so that, hey, it's likely that this is a camera. Or
Yeah. No, we are. Yeah.
by looking at the source and destination traffic and etc.
Absolutely. Yeah, we will know that it's a No, the native discovery will know that it's a laptop, it's a Dell, it's a Latitude 4020 or whatever it might be. We'll understand what that is. But what we don't understand is the context of it. Like, should it have access to everything on my network, right? That's an answer that we have to supply it. And so, but absolutely, we will understand based on the information that we're providing, and we're actually looking at doing. We're actually implementing, more machine learning too. So once we identify a device, we want to understand the behavior of that device. And as devices continue to talk throughout our network, if all of a sudden that device starts speaking to another IP that it's never spoken to and is sending a new protocol, new port, we want to know about that, and we want to actually be able to let you guys know and actually adapt where it's landing in. So we are implementing some machine learning here, but the short answer here is it's not that we don't know what it is. It's just we don't know what to do with it yet, right? And so we're saying, okay, we're going to give it limited access to the necessary services to onboard that laptop, for example, but that's it. And then once he's onboarded, we'll learn about him from Microsoft Active Directory, and we'll learn about him from potentially ServiceNow or whatever you guys are using from the CMDB standpoint, because at that point it would be fully onboarded. That's a great question. And so just the last couple of pieces here, when we talk about building policy groups, the policy groups themselves are super flexible. You have the option of doing dynamic or static. Right? Dynamic is just like it sounds. So you have the ability to come in here and actually start to say, okay, I want to match on Active Directory group. Maybe that member is a group of contractors, for example. And it's maybe we want to make sure that he's a laptop or a computer of some sort, right? It's a computer or a laptop, right? You can actually do you can actually match on ORs as well, so you can make this pretty flexible. So you can be super granular in how you're matching the devices that you're actually looking for, but you can also be flexible enough to add other types or groups of devices to the list of that particular policy group. And this is the group that we're going to use inside of the policies themselves. And so what you'll see is everything is done based on devices. And so we're starting to break it apart based on devices. And so we're seeing which devices are landing into each one of these different groups. And we can start to say, okay, what level of access that we want to give those. The other piece of this, and by the way, the policy groups are completely recyclable. You can use them for any of the different policy sets that you guys are actually using. Security profiles is the other part of this. And so defining, basically, we're introducing the capabilities to create a giant distributed firewall that's centrally managed inside your environment. So we're starting to define these different profiles based on what ports and protocols and things like that we're allowing those devices to speak. So we're getting more and more granular into the policy here, and all of these can be reused for the policy, for any of the policies going forward. Make sense? Okay. All right, and I think the last thing I wanted to leave you guys with was, one of the things that that we talk to a lot of our customers about is, microsegmentation is really, really challenging. We completely recognize that it can be challenging. We tried to take the tech out of the tech debt out of this, right? We try to make sure that microsegmentation is consumable. One of the challenges that our customers run into is just, they can't adopt it because they don't have the resources to be able to do so. So we take that piece out of the equation and we allow our customers to focus on the policy, the good stuff, the stuff that really makes a difference inside the environment. And again, we offer white glove services for all of our customers. So we actually do we'll work side by side with our customers. We have partners that help our customers as well, like big ones like WWT and several others that we're bringing online. But the goal here is just to make the technology adoptable. So thank you for your time.